This is part 3 of the Getting Started series of Genesys, demonstrating the graphing capability within the Genesys platform.
We probably spend more time fussing with graphs than almost anything else in Genesys. Graphs are an important way to see your output and get a feel for what it looks like, so I'm going to walk through this a little bit more slowly. There are two easy ways to create a graph. One way to create a graph is just to go anywhere in your workspace, right-click and pick Add Graphs, and you can add a graph this way. You'll get essentially a blank graph you get to fill in. The other way is what's called Instagraph. I can, for example, click this port, right-click it, and say I want a new graph, and it knows I'm clicking port 2, and I get stuff appropriate to port 2. So let's look at the transient data from port 2. And there's a nice easy graph of the waveform at port 2. If I would like to look at additional data or change the graph, I can do that. Let's go through a little bit of this. Double-click the graph almost anywhere, or just click the properties and go to General, and let's call the graph title Comparison, because we're going to actually compare Harbeck with transient analysis. And we can change the name of the graph too, and we'll call it Compare so it's easy to find. There's our graph called Compare, and we've changed its name, and for the first one we're going to call this Transient Volts, just as a way to label it, and we're going to add another series out of the HB1 data. So we'll add a series, and we'll call it HB1 data dot. So look in the HB1 data file, find the WV port for port 2, and that is the Harbeck volts. So now I've got two sets of data we're looking at. We have the transient analysis compared with the harmonic balance analysis. And as you'll notice, as I mouse over a dot, it tells me exactly which dot I'm mousing over. If you'd rather not see the dots, just go up here to the menu and turn off toggle symbols. And now we just see it as nice, plain, very attractive lines. On, off. There are lots of other ways to fuss with these charts. I can, for example, mouse over the blue and right-click on a dot and pick, oh, I'd like this dashed. Or I guess I got the red. Or I could pick, I'd like the line thickness to be thicker. So now it's thicker still. Let's just go here. And I can say, and I'd like my symbols to be small, medium, or large. Here's the symbol shape I want. I can change the color from here. I can also change the color inside of properties. I can also move the legend around. One way is to double-click it, and it will start floating. So now I have a floating legend. Let's zoom this up a bit. And I can resize the legend, put the legend where I want, change the typeface of it. I can double-click it and redock it. Or I can right-click it and say, let's dock it up at the top, or dock it back down at the bottom. So a lot of ways to play with the legend and the appearance of the chart itself. Now I've also added, notice, data from a second data set. Let's talk about zooming, because in addition to seeing the whole chart, very often you want to zoom in on an area like right here. There are a lot of ways to zoom the chart. One way is to just click and then roll the mouse wheel. And as I roll the mouse wheel, the point I'm at goes to the center and zooms. And if you look down here at the scale, you'll watch the scale reduce, or as I zoom out, go the other way. Now, if you want to get back real quickly, this says zoom to the whole page or zoom to maximize. These are similar but not exactly the same. This is auto-scaled, and this is more or less pretty. Very often you'll get the same endpoint. When I click it, you'll notice in auto-scaled mode, everything is set to auto-scale. But again, as I zoom in, it stops auto-scaling and zooms into where my mouse told it to zoom. I can also pick up a zoom tool and say, all right, I just want to look at that area. I can pick up the pan tool, and in the case of rectangular, I can pan left and right. And just like in schematic, once I've let go of the mouse, I go back to the pointer tool. So that's zooming in and out. I can also pick the zoom tool and hold down the control key, and then I'll just get a rectangle and it will zoom in specifically to the area of the rectangle. And I can always go back to here and zoom back out and take a look at all of the data. And finally, if I'd like to change the boundaries differently, I can do that. Now, this is one kind of rectangular graph. There are lots of different graph types in Genesys, and one of the more common ones has to do with spectral data. I've already got a chart for that, and I ran Harmonic Balance earlier, or Harbeck, with a two-tone input to look at some intermodulation distortion, and that is shown here in HB1 data P2. This chart shows three different data sets, the best, the good, and the original. If I double-click it, you'll see it points at the original data. It also uses the good port 2 data and the best port 2 data to compare the three of these. Now, it's auto-scaled, actually, and the scaling is not very good because the data goes way too high and low. So let's change this to -100 to 20 dBm. Now the chart scale looks pretty good, and you'll notice as I mouse over here, Harmonic Balance tells us, well, you're at the fourth harmonic of the first one and the fourth harmonic of the second one mixed together. So we get to see what it produces. Now, the other thing you'll notice, though, is that, in fact, if we zoom in, there's a lot of data sort of hidden in these spikes, which as I zoom in, we see more of. Let's zoom in again. In fact, that little, what looked like a spike, is actually all of the intermodulation data, in this case for the first harmonic right around a megahertz. This is at a megahertz. And we're seeing a lot of ones because we're within the units that are being shown here. You can change the number of digits, by the way, by going to Tools, Options, digits right of decimal. I have set pretty small so that the graph looks pretty good. All right, now anyway, this is showing us the intermodulation distortion. We've zoomed in pretty well, but don't get fooled by that kind of a chart where you think you just have a bunch of spikes. We can go here, hold down the Control key, and zoom in very carefully on this and see, yeah, we do not have a bunch of spikes. In fact, what we've got is a nice display of the intermodulation distortion. Okay, so that's a spectral chart. Let's go back to our waveform chart. And that would not be this, that would be that. Here's our waveform chart. The other thing that's important with graphing is markers. And Genesys has a huge variety of markers. If I just click, we will drop a normal multiple marker. It marks both traces. You get to see the voltage values, and up there you see the x-coordinate, which is 557 nanoseconds. We can also decide that the marker should be a peak or a valley, or we'd like to see a bandwidth or a delta. For example, let's do a left delta marker. We'll put a second marker down here that shows us that our change is this many volts, and it went there. And if we don't want it to be a delta marker, we could have it do something different. And one way to do that is to actually go to the marker and double-click on it and say, no, we want this marker to be standard. We do not want it to be a delta marker. Or we can go delete all of the markers. Let's go back again and just drop a marker. When we drop a marker and it's highlighted, we can also use the keyboard, left and right cursor keys, to move the marker around left and right for comparing different spots on the chart. We can also decide if we have a bunch of markers that it's getting kind of busy, and what we'd really like to do is see the markers on the right-hand side of the display, and then the markers will line up here, and all you'll see will be the lines and the boxes associated with the markers. And of course, if we decide we don't want to do that, we can just go back to having them float, and we'll see the values here. We can also turn off the marker lines, and then we'll just see values for the marked dots. We'll put the lines back on. I like them. And again, we can go back and just get rid of all the markers. So markers are a very useful and functional way to see the actual numerical data. And that is a moderately good summary of how to deal with graphs.
Thank you for your time. Please feel free to browse other Genesys videos on this website. For more information about Genesys products, please contact your local Agilent eSoft representative or select the More Information Related to this video link on the same page.